morning everyone, welcome back to my channel. Now in this video I will teach you the two types of sets because we are now on the sets types. So the first type of set that we're going to discuss today is empty sets, null set, or void set. Now please do not be confused with these three terms because they are just the same. It's just like they have different terms, but the definition and the meaning are just the same, totally the same. So what is an empty set? But for your information, the most common used word is empty set. So basically, null set or void set is very rare that most of the teachers use these two words, but technically the most used is the word empty sets. So what is an empty set? An empty set is a type of set that has no member or element. So it means there is nothing in it. There is no elements or members in it. For example, like the same with a box. A box without anything in it. It's empty. It's nothing. So how are you going to write the word empty set in a mathematical notation? Because in mathematics we always try to make it shorter, so we mostly use symbols. So in empty set we have two symbols that we considered. This one, a circle with a line in the middle. Okay, so this is an empty set, and the second one is the braces. So as you can see that braces is usually used in writing a set. Okay, but in writing a set using a braces, we put there the members, and the members or the elements are separated by a comma. However, in this empty set, there is nothing in it, so it's just like it's zero. Can you see that? Inside is nothing, so it's an empty set. Now I have here examples how to identify if a given set is an empty set. So the first example, the set of integer between 1 and 2. So we discussed already the definition of integer. It has three types: negative numbers, zero, and positive numbers. Now, if you are going to try to understand the sentence, between it means lawang. So what are the integers between 1 and 2? So since integers are only zero, negative, and positive numbers, and there is no decimal numbers, okay? So if you are going to ask yourself, what are the integer between 1 and 2? So there is nothing integer between 1 and 2. So that's an example of an empty set. Now for the second example, we have set R, x such that x squared is equals to 4 and x is an odd. So odd numbers are, let me try to write here. Odd numbers are 1, 3. Sorry, why it's not beautiful? Hmm. So that would be, hold on. So odd numbers are 1, 3, 5, okay, 5, and so on. Okay, infinity. So comma, comma. So that is the definition of odd number. Now in this particular problem or example, as you can see that the x or the value of x is an odd number. When you square that into 2, you should have a 4. However, there is no odd number. When you squared it, you will come up with 4. So this is an example of an empty set. Okay, because the only number that can be squared to 2 or can be squared that is equals to 4 are only 2. 2 to the power of 2 is 4, and 2 is not an odd number, it's an even number. So it's an example of an empty set. Okay, the letter B, the set B, x such that x is a multiple of 2 and x is an odd number. When you say multiple of 2, it's like 2, 4, 6, 8, 10, 12, and so on, infinity. However, 2, 4, 6 is not an odd number, rather they are even numbers. So this is an example also of an empty set. Next, set E is a set of all elephants who can sing opera in French. Now, in this example, we did not apply um, numbers or mathematics something, but it applied like the real world situation. So you know already elephants. Elephants are Chang, okay, Chang, um, who can sing opera in French. So definitely an elephant cannot sing an opera in French. So definitely this is an empty set. However, if the statement says the set of elephants who can sing, that is not an empty set, because when you're going to go to like Sriracha Park or other parks that has an elephant, they can sing totally. They can sing. However, we just don't understand what they are singing. But in this statement, it shows here that these elephants that we're talking about can sing opera in French, and that is really impossible. So this is an example of an empty set. Okay. Okay, let's move on. So in this example, we will just go ahead and apply the mathematics notations. So the first example, x such that x is an element of z to the power of positive sign. You all know that z is a symbol of integers. Okay, just to remind you, integers again are numbers that are negative, 0, and positive. Now in this example, it shows here that x is greater than negative 1 and x is less than 1. So the greater value of negative 1 is 0. However, 0 is not a positive number. And no one, as far as I'm concerned, I've never heard that they considered 0 as a positive number. However, in other resources, they said that it is a negative and a positive number. So, but technically, most of us, we consider 0 is not a positive number. Okay, so this example is an empty set. Okay, number 2 example, x such that x is an element of z, so the same uh, notation, that will be integer. So x is greater than 1 and x is less than 2. So in this example, there is no integer that is greater than 1 and less than 2. So this is also an example of an empty set. Now for number 3 example, x such that x is an element of natural number, and if you are going to look back on the list of a basic mathematical notation, n or natural number is there. N or natural number, it means these are positive numbers like 1, 2, 3, 4, 5, 6, and infinity. Okay, so that is the definition of a natural number. Now it shows here in this problem that x should be greater than 5 and x is less than 10. The answer there, or the elements here, are 6, 7, 8, and 9. So we have an element, right? So this is not an example of an empty set. So this definitely, it's not an empty set. Okay, so let's move on to the next example. X such that x is an element of integers that are negative sign, and x should be greater than negative 1. So definitely the numbers that are greater than negative 1 are already positive numbers. So this is an example of an empty set. Okay, so let's discuss the last example. X such that x is an element of natural number and x is greater than negative 3 and less than 0. So we have a elements rather. However, it is an empty set because negative 2 and negative 1 is not a natural number. They are negative integers. So definitely this is an empty set. Okay, so you can take a look first in a minute, so you can, or you can pause the video though. Okay, so if you have more questions regarding empty set, and if you don't get it, just ask just ask me and I'll try to help you. And I'm so sorry about the background noise. That is not my dog, it's my neighbor's dog. Anyway, let's move on. Now in this video, the last topic that we're going to discuss is the universal set. Now from the word universe, you know, the entire world, something like that. The universe, or the universal set rather, is just like the same. Universal set contains all the sets. It means from the word itself, all. All, it means หมดเลย sorry, not หมดเลย หมด ทั้งหมด something like that. So universal set is denoted by the symbol, this one. This is only the only one symbol that we basically use in our book. We have only one symbol. So this is an example. This is the symbol of universal. It's like a letter U. Okay. Now, what is a universal set? I have here definition on the top. A universal set is the set of all elements, so remember all elements under consideration denoted by the capital. All other sets are subsets of the universal set. So please do not be confused with subsets. We are not going to discuss that yet here in this video, but it's just like it's part of the universal set. So let me give you a wrap up about universal set so that you can picture it out. Example one. So I'll just give you an example one. I think it's more easier. So given the universe, see the universe 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you are going to consider the cardinal numbers, when you say cardinal numbers, it's like the elements or the how many members that we have in the specific set. So in this universe or universal set, we have 9 elements. And we have two sets. We have A, B. So in set A, we have 2, 1, 2, 5, 6. So how many elements or members? 1, 2, 3, 4. So we have 4 elements. In set B, we have 3, 9. So we have 2 elements. Now I have here the Venn-Euler diagram to represent more or to show more about the universe. So since we have A and B, it means that we have to create two letters. Okay, sorry, two circles rather. So as you can see, letter A is wider or bigger than B because we have 4 elements compared to set B. So sorry. So in this case, what we have to do is we are going to put all them in the Venn-Euler diagram. So I'm gonna write here the universe sign. Sorry, is this okay? So I have to put here the universe. Okay, there you go. You can put here, here, as long as it's inside of the rectangle. Okay, so as you can see, we just have to check on here. We have 1, so this is 1, 2, 5, and 6. So we put all the elements in this one, and then you can put 3 and 9 over here. There you go. So we already put everything inside of A and B, but it's gone. So let's check. 1, 2, 1, 2 is there. 3, 3, 5, 6 is there, and 9 is also there. So this 4, 7, and 8 will be written outside of the circle. So 4, 7, and 8. There you go. So that is a basic introduction of the universal set. Okay, guys. Thank you for your time to listen to our topic, and just log into your Moodle, to your e-learning Moodle, and I uploaded some lectures, and of course I have provided you as well a homework that you need to answer. Okay, so if you don't have any questions, let's end the video with a smile. Okay, goodbye everyone.